Activity 3.2 is much the same as 3.1, but you're going to work with the gear set drawing, which looks like this. All of that same stuff applies, though. This is a standardized format. And so the goal is that instead of just copying this drawing, you use it as a representative sample and you compare your drawing to it when you're done to make sure it looks right. Now, of course, there are some things where the data might be different, or in the representative sample, maybe not even there. It might just be letters instead of numbers, but all the same thing is going to happen. This is very much the same from going to the Gearset in Inventor, Gearset in AutoCAD. Very, very much the same. So let's just take a look. Let's do that review like we did for the other one. And then you can just make your drawings as described in the last one. So let's see what this is like. Usually when you see a gear set drawing, you see the two gears meshed together. You might not have all this detail of the gear teeth. They might just be dashed lines or solid lines. But you'll have nominal center distance. Sometimes you'll see a center mark and sometimes you won't. There will be a tolerance on the center distance. That comes from that whole idea about gear backlash, and do you need backlash, and do you want backlash? And in this case, it's being specified. These isometric views are not always there, but in this case, I had an input shaft on one side that did not go, an input hub socket on one side that did not go through, and on the back side, one that did not go through. So I thought it would be good to have those front and rear isometric. If you struggle with those, they're not super important. But here's the important part. You show the two gears. You say the nominal center distance. Okay. You talk about which one is the drive gear and which one is the driven gear. And then you give the data for those. Now, sometimes that's done in a table, but I wanted to show it to you in a different fashion. So this says diameter dot diameter diameter. OD. Well, you have to go to your gear data and type in the outside diameter. And you have to type in the pitch diameter. And you have to type in the diametral pitch. And you have to type in the pressure angle, the number of teeth, the face width, and the material. Okay, so that's what's going to go on to this one. There, right there. Okay, so you have to fill these out. You have to go to your gear data and fill these numbers out appropriately to this gear set. And then you have to say what the gear ratio is. I, with respect to O, or compared to, or over, that's input, output. So if this was a 1 inch and this was a 4 inch, this would be 1 to 4. Okay, if this was a 2 inch and this was a 6 inch, it would be 2 divided by 6, 1 to 3. Okay, so that's what this is. And so you need to figure those out and type them in, figure them out and type them in, figure them out and type them in. There's usually on an assembly, often the standard tolerances are not there. But let's look and see what else is here. We have our revision history again, like we talked about before. And this number needs to match this letter, needs to match this letter, and it needs to match a master list that's held by quality control or engineering or somebody about what the most current one is. So you can know that you're making the most current product based on the most current drawing. Okay, the title, this. Now, this one does not show the parts list. Normally it would be there, but I need to do much more explanation about an assembly parts list. So I left it off. In general, there is a parts list on there, but we're not going to put it on this time. We'll get to that at another time. Okay, so that's what we've got. So the two gears are shown. The data from the gears are shown, and you have to go to the gear data. You downloaded all that, so you've got it. The gear ratio is shown. The isometrics are sometimes shown. If you can't get them, don't worry about it. Revision block, title block. Okay, and you'll do this once in Inventor, and then you'll open AutoCAD and do it again, and you can use the base file system, the base view system and layout in AutoCAD to use an Inventor solid model. And so again, if you have questions about how to do that, please let me know and I'll demonstrate it in the lab. So there you go. That is really the crux. That kind of covered all of them because we sort of did it before in the 3.1. So that is your 3.2. Look, it's got the same goal. This is just another version of a Gearset drawing.